Hey everyone, welcome back to another math video. In today's video, we're going to be talking about arcs in circles for the geometry course. Let's go ahead and let's get started. So here I have a circle with points A and B, and I have two radius drawn and also point C. So what is an arc? Typically an arc is created when we have at least two radius drawn out. And what an arc is, it's that segment of the circle that's sort of in between those two radius lines. So I'm going to go ahead and highlight an arc that's in between A and B. I'm going to go ahead and draw it in red. Right here, what I'm sort of outlining in red, that's an example of an arc, okay? That goes from point A to point B. And the way I would sort of write down or notate this arc would be I write the letters A, B, and instead of drawing a straight line over them, now I draw a curved line or an arc, and that's how I sort of denote or write down that I'm talking about an arc that goes from point A to point B. We call this arc in particular a minor arc. This is what I would call a minor arc. And then the other arc that goes from the opposite way, that kind of connects point C to the two, and is the other part of the circle. This is an example of what we call a major arc. Okay, and I would include the letter C when I'm talking about that one, so I would say something like ACB, and I would draw a curved line above that, and that's how I know I'm talking about a major arc. Okay, there's another, I guess, term that we should become familiar with, and that's what we call the central angle. The central angle is this angle on the inside of these two radius. Now what we're going to be doing today is we're going to talk about two ways that you can measure arcs. There's two ways that we actually measure arc. The first method that we're going to learn has to do with the arc's angle. What is the arc's angle? When we're talking about the arc angle, we write this little m, just like the same way we would talk about the measurement of an angle, and we write the name of the angle or the arc that we want to sort of find out. So this right here, m, little lowercase m, arc AB, this, when I see this written, it's asking me what is the angle to this arc. Okay, and one thing that I'm going to tell you right now, the key concept in being able to figure out questions that ask about arc angles is that one thing that's special about arcs is that they are equal to the central angle. Okay, so this minor arc out here is equal to the central angle. So let's say the central angle has, I don't know, let's say it's 89 degrees for my central angle. Then I would automatically know that this minor arc's angle would also be 89 degrees. Okay, and this is the main concept that we use to solve questions in geometry that ask about arc angles. So right now we're going to go ahead and we're going to look at a couple questions that ask us about some of these arc angles. So here I have a question, I have a diagram, and I'm being asked for two arc angles. The first one's asking me for what's the arc angle for FE, the measurement of arc angle FE, and then the measurement for arc angle DE. So let's go ahead and let's start off with FE. So from letter F to letter E, they want to know what is this measurement. Well, since its central angle on the inside is 100 degrees, I know that the outside is also 100 degrees. So that one was pretty easy, pretty straightforward. Okay, alright, now they want to know what is the measurement of arc angle DE. And this one's a little bit more tricky because I don't know what its central angle is. So when this happens, there's usually a few rules that we have to remember, or a few concepts or a few ideas. Okay, first let's go ahead, in order to find DE, okay, I know that DE and AF, I know that those two are equal to each other. Okay, which is going to be important. So I'm just going to make sure that those are in red. The other thing I usually like to do is I like to go over the diagrams and see if there are any other angles or arc angles that I could figure out with what I'm given. And I can see here that I can actually figure out what AB is because I know its central angle. So AB is the same as its central angle, which is 50 degrees. But I also know that AB and BC are exactly the same because they both have these congruent tick marks. So BC is actually also 50 degrees. So the only two angles that I do not know are DE and AF, but I know that they're exactly the same. One big idea that you need to remember is that for a circle, you should know that a full circle, if I were to count the whole degrees that make up a circle, I should know that that number is 360. The full rotation around a circle is 360 degrees. Okay, so this right here, that distance is 360. So if I were to subtract everything, all these angles that I already have from this 360, I'm going to get one value. But that value, I can split it in half and find out what D and AF are, because those are the only two pieces that are missing, and they're exactly the same. So I'm missing two pieces that are exactly the same. So if I can subtract all the other pieces, I can just take that missing value, that missing angle that's needed, and I can divide it by 2. So let's go ahead and let's do that. Let's do 360. And we're going to subtract all these angles. Minus 100 from FE. Minus the 50 from AB. Minus the 50 from BC. And minus that 90 that they gave us from CD. Okay? So if I do this and I do this correctly, you should get 70 degrees. So I know that AF and DE have to add up to 70 degrees. But because they're both the same, I can just take the 70 degrees and divide it by 2, and that'll get me 35 degrees. And I know that both of these have to be 35 degrees. So I now know that DE is just 35 degrees. So this is one measurement that they care about when we're talking about arcs. It's the angle of the arc. The other thing that's quite important is the actual distance that that arc line has. So what is the length of that arc? Arc length. Arc length, it's talking about what is the actual measurement in terms of inches, centimeters, millimeters, whatever it is. If I were to take this arc and kind of make it into a straight line, what would that distance be? Okay, what would that measurement be? That's the difference between arc length and arc angle. And for arc length, we use this formula right here. This is the arc length formula. And we really only need two things in order to use the arc length formula. What we need to know is what is the arc angle. So I do need to know the arc angle in order to use the arc length formula. And I need to know what's the length of the radius. Okay, and we plug those in. The arc angle is going to go ahead and get plugged into this equation right here. So the equation is that we take the measurement of the arc angle, we divide it by 360, then we multiply it by 2 pi, and r, the radius. Okay, so these are the values that we need. We need the arc angle and we need the radius, and then we would just plug it in. Okay, so let's go ahead and let's look at an example where we're asked to use the arc length formula. So here they want to know the length of arc JK, from J to K, and we have the two pieces of information that we need in order to use the arc length formula. So let's go ahead. First thing I like to do, I like to write down the formula. So arc length, I know that that is going to equal n degrees over 360, which is just our arc length. I could actually also write the measurement of the arc angle, JK, times 2 pi r. And they gave me my arc angle, so that's what I'm going to plug in up here. And they gave me my radius, which is what I'm going to plug in the end. So this should equal 110 over 360 times 2 pi, and then 8. Again, I'm just highlighting them so that you can remember where they came from. And now it's just about simplifying this expression that we have here. I know fractions can get intimidating, but that's really the hardest part about this problem. Because on this side, I just have 2 times pi times 8, which that's just really multiplying the 2 and the 8. We're going to leave the pi alone. So if I simplify this fraction, I can cancel out these zeros and I get 11 over 36. If I multiply the 2 and the 8, I get 16 pi. And now I just got to multiply 16 times 11 over 36, which if you do this correctly, you'll get 44 over 9 pi. Okay, so you might be intimidated by this because it involves some simplifying the fractions, but I'm sure you'll get it and you'll pick it up. Don't be intimidated. Use your brain. You can do it. All right. And this would be the second portion of arcs. There's 2 things that matter when we're finding arcs: arc angle and arc length. So hopefully now you feel comfortable with what an arc is inside a circle, and also that you're comfortable with finding the arc angle and the arc length. We're going to be working with circles for just a little bit. These are very good things to be able to find out. Hopefully you found them helpful and they help you in whichever class you're in. As always, I just want to thank you for watching, and I hope that you continue to learn some math.